Welcome to this comprehensive video tour of the Dessia bot platform, where we will provide you with an in-depth exploration of its features and functionalities. We will introduce you to a simple use case whose objective is to generate a set of 3D Li-ion battery packs. As input, we have the 3D shape of an elementary cell and a 3D implantation volume. The goal of this bot is to generate all possible ways to place the cells in order to find the configuration with the maximum number of cells. The objective of this tutorial is to build a bot that can find all these architectures using elementary components. We have 3 elementary components at our disposal. One component that can build an elementary volume composed of 2 cubes, a second component that can generate all possible battery modules, and a third component whose objective is to fit the maximum number of modules into a given implantation volume. Each card in the bot store corresponds to a component, and by clicking on the 3 dots and selecting Edit Bot, you can display the corresponding workflow. In this initial introduction, we won't go into detail about how to build these elementary workflows, which correspond to a more advanced usage of the platform. By clicking on Bot Store afterward, you can return to the central page for managing all the bots. First, we will create a personal organization with a name of your choice, which can be your name or your company's name. The name you choose must be unique on the bot instance. If the name is not valid, you can try another one. Then we suggest creating 2 different workspaces. The first one can be named Toolbox Battery, and the second one Bot Battery. The first step is to bring the elementary bots into the Toolbox Battery workspace. To do this, go to the Bot Store page, click on the 3 dots, and then from the Share To menu, share them with the appropriate workspace. The first bot we are going to build is a bot that generates the implantation volume. To do this, create a bot from the Bot Store by clicking on the button in the Bot Battery workspace. You will be taken to a blank workflow page, and from the icon at the bottom left, bring up a menu bar. Then select the Toolbox Battery workspace, and you will have access to your previous bots. Next, bring the Generate CAD component from the workspace to the workflow. It will appear in the center of the page, and by clicking on the spacebar, you can center your entire workflow. We will add a CAD post-processing step to this workflow. To do this, choose the CAD View tool from the Add Block tool. A panel will appear, and you can give it a name of your choice, such as CAD View. Then from the workflow interface, connect the output of the previous block to this post-processing block. Your workflow is almost complete. You just need to double-click on the output port of the first block. This indicates the workflow's output that you want to store in the database. Before closing the page, name the workflow and click on Save as New. Then you can go back to the Bot Store, and you will see a new bot appearing. From the Bot Store page, you can run this bot by clicking the Play button. A form will appear, corresponding to the necessary inputs to simulate your bot. For example, you can enter the values 1, 0.3, and 0.2 for the definition of the first box, and 0.45, 0.8, and 0.4 for the definition of the second box. Then, enter a job name and click Submit. You will be taken to a bot launch interface, and after a few seconds, the calculation will be completed, and you can click on the created output object. You will be directed to a generic page with a tree on the top left to navigate through the result object. In this specific case, we have only provided a CAD view display, so by clicking on this view, the corresponding 3D view will appear. Now, let's create a bot whose objective is to generate all possible electrical cell arrangements that fit within this volume. Go back to the Bot Store page and create a new bot from the Bot Battery workspace. Similarly, bring the components corresponding to the Toolbox Battery workspace. The output of the Generate CAD component is required for the battery generator component, so connect its output to the input of this bot. Similarly, the output of the module generator component provides cell arrangements to form elementary modules, and these elements are necessary for the operation of the battery generator component. In a similar manner, connect its output to the modules port of the battery generator component. Double-click on the output port of the battery generator component, and now we will add some post-processing. Add a CAD view post-processing similar to the previous example, and connect this block to the output port of the Generate CAD component. We will add a multiplot post-processing, which is a graphing system that allows you to navigate through all the proposed solutions. From the Add Block tool, add a multiplot block. This post-processing requires defining the variables of interest that you want to analyze. All these variables are to be entered from the displayed vector in the window. We suggest including the main parameters, namely number module, number cell, mass, length x, length y, and length z. Be sure to spell these variables correctly. Then give a name to this block, such as multiplot, and connect it to the output of the battery generator component. Similarly, give it a name and click on Save as New. Back on the bot store page, you will see a new bot appearing. Similarly, you can run this bot by clicking the play button. The first fields correspond to the dimensions of the envelope volume that we detailed, and you can use the same values. Then the cell size field corresponds to the size of an elementary cell. For example, you can choose 0.03, 0.15, and 0.103. The second field corresponds to the minimum and maximum number of cells you want to have per module. The exhaustive generation relies on decision trees, so the calculation may take time if you choose relatively wide ranges. For example, you can choose 2 and 8. Then enter the mass of a cell, for example, 1, and finish by entering a job name and clicking Submit. The calculation may take several tens of minutes depending on the parameters you entered. Once the simulation is completed, you can go to the post-processing page of the bot by clicking on the simulation accessible at the bottom of your bot's card. By clicking on Multiplot, you will display the post-processing system that allows you to navigate through all the available solutions. Using the available graphical selection tools, you can select an area of interest. Then, all the selected points will appear in a table at the bottom. You can then open each of the solutions by clicking on a particular line of the table. A new window will open, and similarly, you can display the CAD of the solution. We will focus on a first solution, which corresponds to the one with the most modules. Similarly, the 3D view is displayed by selecting the CAD view. Then we will move on to a second solution, which corresponds to the one with the most cells. After selecting your optimal solution, you can export the 3D in the format of your choice or share the object with your workspace. What we have shown corresponds to a manual selection mode. We can add clustering algorithms to assist in choosing the optimal solution. This first tutorial gives you a brief overview of the potentials of the Dessia platform. We invite you to create a demo account on our platform so that you can try to reproduce this tutorial. For more details on all our functionalities, we invite you to contact us. Thank you for your attention.